levels should be fairly fast, so I'll get started. The first one is basically the canonical reflection attack. So that's what we'll do here. We're going to just access the lab. Oh, I have to log in. Let's see here. So here is the original reflected cross-site scripting, and then this is basically the example that I showed you in class. If you search for anything that's got HTML tags, it basically is reflected back into the page and nothing gets encoded. So actually, I don't want to solve this immediately. So if you search for the brackets, and you'll see that this, if you inspect this page, actually what you will first want to do is just view the page source. And so we'll talk about this later on in this sort of lab, but there are two ways of looking at the page. The first way is to view the page source to see the raw HTML and the raw scripts that come in. The second way is to actually inspect the page in the developer tools. And in the developer tools, it gives you the DOM after it's been rendered. This is the runtime view. And so you will see when you do the view page source, what you have been given back is the raw thing. And then in order to get the dynamic view of the page after DOM elements have been created and filled in, you'll need to hit the developer tools for that part of it. And we're going to be needing both in this particular set of exercises. So that's what I wanted to show you here. Let me see. This is the original view. And so this does fill in the actual payload that you searched for. And so that's fine. I want to see if this is the exact thing that comes back when I do the view source or the developer tools. And so if I inspect this thing, and I poke through all of these containers, one of the things that you will see is where this thing, I should have picked a different form. So say I do this. So I inserted my own Odin ID as a tag, and you can see that the search results don't have what I searched for in the tag. And then what happens here is if I inspect the page, inspect this page, you can see in the header that I have this tag showing up and being parsed by the DOM, by the page itself. So this is being treated as a tag rather than as data. So that's the vulnerability. And you see that the DOM, they automatically assumed that I needed a closing tag on this. So the JavaScript engine or the rendering engine is like, hey, you need this. Oh yeah, Control F, thanks. So that's what you need for this one. So I'm just going to do the canonical cross-site scripting attack on this particular page and then solve the level. And then, so that's the first level. Okay, and so this is the next one. Let's see, the next one is HTML context with most tags and attributes blocked. So that's what this is. Okay, let me get rid of that one. And so what you'll see here is that the original program, the original script, I have you send it in as a search term programmatically, and you can reverse engineer this to see that it's basically the main page. And if you send the main page a URL parameter that has the search term, it will execute that search. So what you'll do is you'll send this in, and then you'll see what the response code is. So that's basically the first thing that I'm going to do is send the original payload in. So whoops. And then I'll search for this. And you'll see I get a, if I actually inspect this, do that again. Tag is not allowed. And in the network connections, you can see that this thing, this thing has the headers, and it's a 400 bad request. Okay, so using that, we are now going to see whether or not other tags are allowed. So we know the script tag is not allowed. And so one of the things that you might want to try is a body tag. And you would do this brute force, actually. What you could do is you take all the HTML tags and you could brute force whether or not any of these tags are available for you to use. So let me do this. Send a different tag. And if you inspect this element, you can see that the body tag has been consumed, and you get this the original thing echoed back into your page. So that's interesting. The content was used and the tag was consumed. And so one of the things you might think of is to do something that looks like this, where if the body tag is actually consumed and executed, I could do something that looks like this, right? And I can see whether or not this thing will actually send me an alert when the page gets loaded. So that's what I'm going to do next. And you see that the attribute is not allowed. So there's some next level filtering going on in this page that says the body tag was allowed, but then this attribute, and that's what these things are called. These are called attributes in HTML, tag attributes. This thing was blocked, so I couldn't do the alert one. All right, so this leads me to the brute force attack. And so this particular code lab, I ask you to write a program. And this is the program that you'll end up developing. And it's got a try search function, which says do the search and then see what kind of status code you get back, just to see whether it succeeded or it didn't. And then I have it search for my Odin ID. So I try the original search. I should get back an error. I try a body search with my Odin tag, and I should see that that actually is allowed. And then I'm going to brute force search all of these different attributes in the body tag to see if every single body tag is blocked. And you'll see that one of them isn't blocked. And that's what I'll do next. So I'm going to execute this script. I'm going to get the URL. And then I am going to paste it into my program. And then I'm gonna run it. And so let me make this just a little bit bigger. I'm going to search for the original payload, the alert, and it's going to say tag is not allowed, as we saw before. I'm going to search for the thing that we searched for before, the body tag, and this gives you a 200 saying it was allowed. And then I'm going to search all of those different attributes in that list that I showed you and see if they're allowed. And so I'm going to see, on load, does that work? And it gives me an error, attribute not allowed. The on unload, this is not allowed. The on error, not allowed. On message, not allowed. On page hide, not allowed. On page show is not allowed. On resize. And on resize, you can see this has been allowed. So when the page is resized, you can inject a piece of JavaScript that will perform an alert. So that's pretty good. So that's actually the vulnerability here. On storage, so you could actually do an on storage attack as well. And so that is what I wanted to show you for this particular exploit. So the goal of this exploit is to then deliver a particular exploit to a victim, and for the victim to click on it and then expose his or her document cookie. And so as part of this particular level, they provide you with this exploit server. So I want to show you this. And this exploit server, and this is, I think you've had this in earlier exploits. The exploit server is just slightly different across the different exploits based on what your goal is. And so the idea of the exploit server is that you want to deliver to the victim some content that the victim will periodically access. So the victim is periodically accessing the /exploit route, and then you're able to store the content that's in this /exploit route. So if I store this, this will actually, if I then view the exploit, you'll see that hello world is in there. Okay, so I'm going to show you how this works programmatically. In your Python program, I have code that allows you to parse the exploit server's link from the main page. And so you can see it basically goes to this part of it and then parses out the href from it. And then what it does is I'm going to show you a demo where the first thing I'm going to do is send to the victim a heading that's got my Odin ID on it. And then I'm going to store this payload onto the exploit server. And that's what this form data is. You basically get, you fill out the form as we saw it in the exploit server. So on the exploit server, there is this form. And then as part of submitting the form, you would set the different form values based on the button that you want to push, and then the elements that you see here. And that's what my program does. The heading, the path that I want to store it on, the actual payload that I'm going to store there, the action that I'm going to do. And that's what this thing does. And so I am going to post, sorry, you're not supposed to see this part yet. I am going to post just this thing to show you that this code properly posts that thing. So that's what the next part of this program is doing. Okay, and so if so that's this part of the, that executed this part of the program. And so then I'll go back to the exploit server and I'll view the exploit. And it should have got, what? That didn't work. Did I not, hang on a second. That should have worked, unless the level changed. Okay, oh, dude, I have to go through all this again. Oh, I should have commented it out. All right, so then I stored that, and this thing, once I reload this thing, that didn't work. There's this access log that shows you the accesses that are made here. And so this thing actually has my request in there. Let me, I wonder if this is actually going to work then. Storing the iframe. Oh, man. All right. So, darn, I solved the level. Let me show you what solved the level, because I give you this payload anyway, because I don't really want you to have to develop this yourself. So the thing that solves the level is basically putting up into the exploit server a link to this search term, and then setting the width of the iframe to something super small, and then forcing a resize on that iframe. And then the iframe, because it's got the, because it has the on resize, the alert document cookie, this will, any browser that visits this, including the victim's browser, will automatically resize the window, causing the alert to trigger. So sorry about this not working. I have to figure out why this didn't show up on my demo. So that is reflected number 2. And this is actually an advanced level, but I put it here because it fits in with some of the other exploits, and it allows me to show you how to access some of these things programmatically. Okay, so that's the second one. Are there any questions about this particular level? Okay, the next one that I want to do the next one, I'm going to do number 4, where the attribute angle brackets are HTML encoded. So I'm going to instantiate this level first. And so the first thing that we're going to do is we're going to, again, search for our HTML, our Odin tag in the HTML. And then we're gonna look to see where this thing is reflected back at us. And so if this content, if this search term is reflected back in multiple contexts in the page, you have to make sure that each context has been encoded properly based on what the context is. So in this case, I am going to send in this tag. And I am going to inspect where this tag comes back. And so this time I will do the Control F. Wait, it does not. Okay, so I am going to search for this tag. And you see this has been properly encoded. Actually, you know, it's actually better if I show you first the page source. So if you look at the page source, this is before the rendering happens. If you look at the page source, you can see that the search results in the header have my name, but that tag, rather than actually being sent as an HTML tag, has been HTML encoded because the context for which you include this content in is HTML. So you don't want that thing to be parsed. Likewise, within the input tag, you see that there's also my name is appearing, but then this has also been HTML coded. And so back in the actual page, you can see that when you search for this tag, it pre-fills the input field of the following search form with your original search term. And so you have to make sure on both of these contexts that you have done the proper encoding. And in this case, both of these things have been properly encoded, HTML encoded. But one of the things that you'll note is that this thing got injected back into an HTML attribute. So you have to make sure that not only is the content HTML encoded, but that you can't inject a double quote to break the syntax of the enclosing tag. And so that is the vulnerability in this particular level. So even though this is properly done, whether or not this is vulnerable to attack is another question. So one of the things that we're going to try is to see if a double quote will break the syntax of this attribute itself. So that's what I'm going to do next. So I will give it this string. Say I would, I want to see if I can break the syntax of the attribute and then create a new attribute and then use the double quote that would have enclosed the attribute otherwise to fix the syntax of this thing. So that's what I'm going to do. I'm going to search for this. And you can see that even though the search term had this in it, the attribute seems to have been consumed in the input prefill. So again, we're going to view the page source before it gets rendered. And then you can see that even though the script tags got encoded, the double quote actually broke the syntax on the enclosing input tag. So that's what this vulnerability gives. And I want to show you the program again for solving this particular level. So I'm going to go back here. I'm going to get the host name of this thing. And then I'm just going to do the search term and return, search for the search term and return the response. I am going to show you the original one and the results that you get back in the heading, as well as the results that you get in the input search field. So that's the first part of this. And you can see the same thing that you got before. And then I'm going to search for that second search term that you saw before. And then you can see that the input tag has the extra attribute associated with it. And then what I'm going to do is I'm going to search for this, where it injects on the input attribute the on mouse over attribute, which basically pops up an alert as soon as you mouse over that input field in the UI, which is next. And then that should solve the level because the simulated user will then access that thing. Okay. Are there questions about that particular level? All right. So that's 4. We'll go to the next one, which is number 5. And this, they tell you JavaScript string single quote / escaped. So that's basically what this is, the solution or the level 4. Okay, so this is your search UI, and so they tell you that the cross-site scripting vulnerability injects into a JavaScript string. So one of the things with JavaScript strings is that they're quoted, they're either escaped with, or they're denoted with single quotes or double quotes. This is telling you that it the single quote and the / are escaped. So let's see what the facility is that does this thing. And so you can see when I search for a single quote, you can see what happens on the response. And so you can see that the single quote is first HTML encoded. Then you can see that there's a JavaScript program here that says, oh, you know, for your search term, pull out the search term that you got. And in this case, because a single quote would break syntax, this particular web application is trying to do the right thing, is trying to / escape the single quote, which is fine. And then it's going to document.write the search term into a tracker image. So on all of a lot of these levels, there's some kind of tracker image that will track the access to the search engine based on the term that has been used to do the search. And so you send this tracker image the payload of what got searched, and then you encode it so that you don't include any injection vulnerabilities. And so that's the vulnerability here, or well, that's the countermeasure to prevent vulnerabilities here. But when you're doing this, you have to not only worry about the single quote, you have to worry about everything else in the search term that might be included. So you have, let's see if script tags have also been handled appropriately. So that's what we're going to do next. So this is a thing that you'll be doing a lot of. Let me create a tag for my Odin ID. And then you can see, oh, there are no response. There's no, obviously there's no product that's got the script tag in it. And so let me go and look at that tracker image to see exactly what it uses as a tag. And you can see here, this has not been HTML encoded, the tag fields. And so when you include this in a tag, what you can see is that with this single quote, or with this encode URI component, you have the potential of inserting a tag that will disrupt the DOM in this case. So that's the vulnerability here. And so what happens if I instead search for this? So that's what I'm going to do. I'm going to search for /script, and you see something really crazy show up in your UI. So let me do a view page source on this thing. And you can see what has happened is that I've included this /script, and the document.write is just going to blindly write that thing out. And so at runtime, so this is basically static. This is the static page. And then when it gets executed, you'll see that this dynamic execution is going to inject a /script tag after this image source tag that's been produced. And so this is where I want you to focus on. And you can see that if this script tag is injected, so this when this thing gets parsed, this script tag is then going to have, if it ends this particular JavaScript, it's going to have this text show up afterwards, which is what you see here. So this should look familiar to you because this basically shows you that this thing is actually going to end that particular line of code. So that's what I'm going to do next is inspect this. And whoops. And this is what you can see. So dynamically, this script tag ends this thing, and then you basically have this being pulled into as outside of its JavaScript context. And this is where you'll see this thing end up on your page. So that's a vulnerability. So one of the things I can do is, because I have the ability to end this script, I can inject another script tag right after this. And that's what I'll do next. So I can then do this and then get the alert to show up. Okay, so that is that level. The next one that I want to do is, let me see here, reflected number 6. I'm going to skip this one. And in this one, the JavaScript string angle brackets are HTML encoded. So it's basically fixing the vulnerability that I just showed you on the other level. So let me instantiate this level. And so the first thing this level asks you to do is to try and use the previous level's exploit on this thing. So that's what I'm going to do first. I am going to see whether or not the, if I end the script and then I call another script to execute this, see if that works. And then you can see it doesn't. So I'm going to view the page source to see what happened. And you can see in the heading, I have proper encoding being done. In the JavaScript itself, that term is also properly HTML encoded. And so you can see I can't break this thing. I can't inject an ending script tag. So I have to find some other way to do the cross-site scripting attack in this case. One of the things that you'll see is that, hey, these strings in JavaScript, in this JavaScript code, the strings are denoted by single quotes. So I have to make sure I've handled the single quote appropriately. So that's what I'm going to do next. To see what happens if the single quote is sent in. And then it doesn't appear to do anything, but I'm going to inspect this page. And you can see the single quote is, well, you can't see that how this thing is parsed, but this is actually going to give you a I needed to put this in the browser tools. You can see that this this particular single quote is going to lead you to a problem in the console. And so you'll see that there's an invalid or unexpected token in your page. And this is because when you go back into the page itself, into the view source, the JavaScript interpreter does not like this line of code because it likes an even number of single quotes, and it likes this. This is not an expression JavaScript likes. Like if I actually did this and then put it into the console, you got the invalid or unexpected token. So this single quote is actually breaking syntax on the underlying tracking that's going on in the page. So you can see that this particular tracker image, this link is broken, and you probably won't see this script actually execute. So when you are in this page, if I go into its elements, this is the page itself. You don't see an image tag anywhere because this script fails. Typically, the image tag, when you do this document.write, would have shown up in between these two things. And in fact, I can actually do that. And you can see right after the script, you can see that the image tag that the script produces follows right after. If I inject that single quote, you can see that this just causes the script to fail, as you see up here. And then the same thing. There's the script. And then after the script, you don't see the image tag because this whole thing, because you escaped the JavaScript string. OK, so the next thing I want to do is maybe I can insert the single quote and then insert a semicolon, so recreate the syntax, and then comment out the last two characters, and then reform JavaScript. So that's what I'm going to show you next. So in this case, I will break syntax with the single quote. I'll end that statement, and then I'll see if I can put in a JavaScript comment. And then this should actually give me that tracking cookie. And if I inspect this page, you can see that it is there. So I have a null search term. I have commented out the previous single quote semi. So these are the two I injected, and then I injected all of this, and these were the original two. And then you can see everything works again, and then my search term doesn't turn out. OK, another thing I can do is since I have actual JavaScript I'm able to execute, I can actually do this, redefine the search term, and make it equal bar. And then I'll have that single quote semicolon on the other side of this to change the search term into something else. And so if you look at this, the search term is this. And then if you look at the image that got written out, you see the image has the search term of bar. And then you can see the JavaScript that gets executed has the search term being set to null, and then the search terms being set to bar. And that ends up with the image that is set to bar. So this is, I've gotten code execution within this page. So then I'm going to finish the level. So what I can do is I can break the syntax of that string again. I can just issue an alert on this thing. And then I can basically, after that, I can just, whatever. I can put anything on the other side of that. I think I might need the semicolon. I'll put the semicolon in there just in case, and then I'll solve this level. Okay, and if you inspect this, I think you will see the script, and you can see that this is what gets executed on that script. Okay. So that is another one of those. I'm going to do one more and then save the rest for next class. I'm going to do the last one. The last one is breaking template literals, JavaScript template literal strings. So we've been using, in this class, we use Python F strings. They're like parameterized strings that form a template, and then you fill in the template with the actual variables, the values of the variables. In JavaScript, they have something called template literals, which are the same. You have a literal string that's a template, and then within that string, you can fill in the different quantities. And so this particular vulnerability injects into one of those templates. So it's just another way of doing this thing. And so I'm going to, well, first, I'm going to have to instantiate this level. This is a pretty short level. It's an interesting vulnerability that as soon as you know the trick is really easy to exploit. So this will only take me a minute. And that's what I was saying, you know, like we've done the vast majority of the reflected labs in basically like 40 minutes. So don't get intimidated. You'll see this code lab and be like, oh my gosh, he is really crazy. So I assure you that it'll be faster than it looks on this one. I know I've loaded you quite a bit so far. Okay, so I actually give you a lot of the information on how this level is done. So this is the syntax of a template literal. So you don't have to put an F in front of the string in JavaScript. What you do is you use the backticks. And so the backticks say that this is a special kind of template literal in JavaScript. And I want you to take this $ curly brace notation and substitute the value of this variable in to this string to generate the actual string variable. And so in this case, the value of name is my Odin ID. And so this will set the email to my name, my email address. Okay, and so you'll see this if you go to, well, you search your Odin ID in the blog first, and then you can go and see where this is included in the response that you get back from the page. So that's what I'm going to do first. And then in the page source, you can see that, I have the script, and this is done with again, I'm using a template literal and filling in the search term for this particular name. And so this message is getting generated dynamically by the script. And then I'm going to grab an element ID that has the search message box, which is basically this heading right here. So in previous levels, I would generate that like on the server side. The way this is being generated in this level is to create the original element and leave it blank, and then attach a script that will basically take the search term and include whatever the search term is into this template literal, and then modify the DOM element directly after the page load, after the JavaScript engine executes. Okay, so I want to see whether or not my search term will get consumed if it's a template literal, right? Like I can actually give this template string a literal, or not a literal, the actual variable that it is looking for. So that's what I'm going to do next. I'm going to search for what happens if I have a string, and you see this here, that is CS $ and I do 490 plus 5. And so the idea is that if this is being done in a template literal, and if this is being treated as a variable, the JavaScript engine is going to add these two numbers and then give me 495 back as the result. So that's what I'm going to search for. And then you can see it has actually done that. It has added 490 and 5 together and given you 495. And you can see that this template literal shows up. And because I'm using the backticks, the JavaScript engine will now evaluate that sum and then produce the result. So this is easy to break then. So how do I get the actual alert to show up? I can do something like this and then just give it JavaScript to execute. And then you can see this will pop up a page, solve the level. And you can see that the result of that execution returns a result that's undefined. Like if you just do an alert 1 in the JavaScript console, you get the undefined result back. And so you can see alert 1, it gives you CS undefined because that's the return value of alert 1.